Hey, mathematicians, how are you doing? Today, we're going to be bringing back absolute value and be applying that to inequality. So again, we're going to continue to stretch a little bit. Remember to keep asking questions as you have them. You know, we're not expecting you to be experts right away. It's going to take time to learn the skill and practice the skill. So here we go. So just a reminder that absolute value is the distance a number is from zero, and it's always positive. And we use these bars to designate absolute value. Okay. And so when you see that, absolute value means distance from zero. And because there's two sides of zero, there's usually always going to be two answers. Now, the exception to that rule, because there's always exceptions, right, is zero. You know, if we end up with x is the absolute value of x is greater than zero, well, zero is where we take it from. So that's what we're looking at right here. So let's take a look and get through some examples. If needed, we're going to use so when we're solving inequalities, if needed, you're going to use inverse operations to isolate the absolute value bars. We need to get these bars all alone first. Before you can do anything else, we have to get them all alone. Okay, then we're going to set up two inequalities, okay? One is going to compare to the negative side, and one is going to compare to the positive side. And we're going to talk about how to do that. And then you're going to graph each case and write it out. So there's quite a few steps in this, but what we want to do is take an opportunity just to walk you through those steps. So this will be a good slide to go back to kind of cross-reference, remind you, but as we go through, this is what we're going to be looking at doing. So here we go, okay? First problem, the absolute value of x plus 3 is less than 12. Now, I know I went through the steps really quickly. I'm going to take it slower here, okay? So step one, we have to make sure our absolute value symbols are alone. And you know what? They are. There's nothing else on the side, okay? And now what we're going to do is we're going to write two inequalities. Again, twofer, it's a deal. Teachers like deals. You're going to do two inequalities in one problem. So what we have here is we're going to say that x plus 3 is less than 12. Okay, that's the first one. So we're rewriting it without the absolute value symbols. And the second one is that x plus 3 is, now watch this, watch. We are flipping the sign. It is greater than, and we're taking the negative. So it's greater than negative 12, okay? So when you look at this, you can see that we're making two changes to it. The first one we're just going to keep as x plus 3 is less than 12. The second one, we're going to change the sign and make the 12 negative. Now we're going to go through and solve these two inequalities. So I'm going to subtract 3. So x is less than 9. I'm going to subtract 3. So x is greater than negative 15. And again, computation is really important in this piece. We really want to pay attention to how we're adding and subtracting and make sure that those numbers fit. Okay, so my first step was to make sure the absolute value symbol was alone. The second step was to make sure that I had my two inequalities and I solved them down. Now my third step is to graph it. So what I'm going to do is a lesser number to the left, greater number to the right. I keep repeating that so I remember that. It looks like both are open dots. I have to figure out which way I shade. X is less than 9. Okay, so something less than 9 would be 0. That's telling me I shade this direction. So it looks like to me that this is an and statement. I'm joining them together. And so I'm going to write the inequality as negative 15 is less than x, which is less than 9. Lesser number to the left, greater number to the right, variable in between. Variable in between, right? Let's take a look at the next one. Step one, absolute value bars need to be alone. They are. There's nothing else added, subtracted, multiplied, or divide to them. Step two, we're going to create two inequalities. Now, the first inequality is going to be just like the inequality we have. 3y minus 9 is greater than, or 3y minus 3 is greater than 9. Now, the second step is to write an inequality that flips the inequality sign and makes that 9 negative. So it becomes 3y minus 3 is less than negative 9. Notice how I flipped the sign and made it negative. Now my step is to solve these. So we're going back to what we started the unit with, solving inequalities. I'm going to add 3 to both sides. So I have 3y is greater than 12. Divide by 3, y is more than 4. I'm going to add 3 to both sides. 3y is less than negative 6. Divide by 3, y is less than negative 2. Okay, so I solve each of those inequalities. From here, I'm going to then graph it. Okay, lesser number to the left, greater number to the right, open. Okay, now I got to figure out how to graph it. Y is more than 4. So y is more than 4 goes this direction. Y is less than negative 2 goes that direction. Okay. Now, I'm going to write the inequality below. Y is less than negative 2, or when it's an or statement, we actually put the word or in it. We practiced that a couple days ago. Or y is more than 4. So now I have my answer. Okay. Again, I'm going to continue to work through those steps we talked about on the previous page. Get the absolute value alone. Create your two inequalities. Solve each inequality. Graph it. Write your final answer. All right. So here we go. On this next one, I have the absolute value symbol all by itself. So next step is to write out the two inequalities. So 4 plus x is greater than or equal to 7. This next one, I change the sign and make it negative. 4 plus x is less than or equal to negative 7. Solve each inequality. Subtract 4, so x is more than or equal to 3. Subtract 4. X is less than or equal to negative 11. Okay. So now I need to graph it. Lesser number to the left, greater number to the right. X is more than or equal to 3. So I'm going to fill it in. Shade to the right. X is less than negative 11. Shade in, shade to the right. X is less than or equal to negative 11. X is greater than or equal to 3. I put the word or in between. All right. Put that there. I have my answer. Okay. So what we're practicing is how to solve an absolute value inequality. We've solved absolute value equations. Now we're solving absolute value inequalities. Okay. All right, here we go. Here we go. Two problems. These are going to have to involve the first step. We have to first get the absolute value symbol all by itself. So here we go. I'm going to add 3 to both sides. So the absolute value of 2x plus 1 is greater than 9. Now is when I divide it up into two separate ones. You have to have the absolute value symbol all by itself. So here we go. I'm going to write it as 2x plus 1 is more than 9. I write the exact same problem except no absolute value bars. Same problem. And then the second one is where I switch the sign and make it negative. Switch the sign and make it negative. First, I got the absolute value symbols by itself. Second step, get my two equations. Now I'm going to solve. Minus 1, so 2x is more than 8. Divide by 2, x is more than 4. Solve the other one. Subtract 1. 2x is less than negative 10. Divide by 2, x is less than negative 5. Okay. Now I'm going to shrink these down a little bit so that I have a little more room to work with my graph. Okay. So when I plot them on the graph, I put my lesser number to the left, greater number to the right. Both are open circles. X is more than 4. So more than 4 goes to the right. Less than 4 goes to the left. I see that gap, so it tells me it's an or statement. X is less than negative 5, so that's representing this part, or this part is that x is more than 4. Right there. X is more than 4. All right. Let's go with this next one. And it's a lot. Feel free to pause, take a, whatever you need to do as we go through this. So I'm going to subtract 4 from both sides. My first step is to get that absolute value symbol all by itself. So the absolute value of 3x minus 3 is more than 6. Okay. Now that it's alone, I can separate it. So 3x minus 3 is greater than 6. 3x minus 3, switch the sign, make it negative. Switch the sign, make it negative. Okay. Now I go through and I solve each problem. So I'm going to add 3 to both sides. 3x is more than 9. I'm using my equation solving skills and applying them to an inequality. X is more than 3. Here, I'm going to add 3 to both sides. 3x is less than negative 3. Divide both sides by 3. X is less than negative 1. Okay, so now I'm going to shrink these down. This is a lot. I'm really proud of you for hanging in here. I know that this isn't necessarily easy, but it's totally doable. We work hard, we're going to do just well with it. All right, lesser number to the left. Greater number to the right. In this case, they're both open dots. X is less than negative 1, shades to the left. X is more than 3, shades to the right. It's an or statement. So when I write my answer out, X is more than 3 or X is less than negative 1. Dum, dum. All right, one more problem and then I'm gonna let you get going. Okay, so here we go. Kenny. He kicks for his football team, his high school football team, and he earns a team point for every point after touchdown, and he earns 3 points for each field goal. His goal is to score at least 12 points per game. So we want to write an inequality to represent all these possibilities, okay? So we know that we have a point after touchdown, and we have 3 points for a field goal. So he wants to score at least 12 points. That means it's more than what he scores is more than or equal to 12. The point after touchdowns are my x's. So 1 times each point after touchdown plus 3 times every field goal. So in football, field goals are worth 3 points. And then after a team scores a touchdown, their kicker can go kick for a bonus point and an extra point. So for those of you not familiar with football, that's kind of what we're talking about in terms of the scoring. So the kicker is responsible for kicking those. So the inequality is 1 point times every point after touchdown plus 3 times every field goal. He wants to score at least 12 points. So if he scores 5 points after touchdowns and 2 field goals, does he meet his goal? Okay, so we've got 5 times 1, so that's 5 points for the point after touchdown, and 3 times 2 field goals, that's 6 points. Is 5 plus 6 more than or equal to 12? Nope. He didn't feel, even though he scored on 7 different occasions, he still didn't reach his goal of getting 12 points. So, all right, that's all for right now. If you've got further questions, please reach out. I look forward to talking to you soon.